Hey, this is Steven from the Green Engineers, and welcome back to my research video series. And we are back looking at some more 3D printer materials. So we are back at 3DXTech, and we're going to be looking at some of the rest of their filaments that they have. One second, sorry about that. Or the ESD. I think I might have missed grabbing one. Anyways, we're going to basically be looking at, this standard polycarbonate. Okay, let's have that over there. So we're going to be looking at the rest of their filaments that they have. So already in our first video, we looked at, first video of the 3DXTech, we looked at all their carbon fiber reinforced filaments versus their standard non-filled counterparts. We found out how much the chopped up carbon fiber adds to the rigidity, and that was their Carbon X line, carbon fiber 3D printer material. So we are looking at the ABS, obviously ABS versus ABS and PLA versus the sorry about that, I forgot to turn that off. ABS, PLA, and then versus polycarbonate. We got polycarbonate, ESA, ESD safe polycarbonate, ASA polycarbonate, PETG glass filled, PETG high temperature, and yeah. So we're going to be basically comparing it to all the, I had that twice. So I believe I should have all of them labeled on there. So again, we're going to look at this polycarbonate. These two are ridiculously high extrusion temp, like 330C. So I'm not even going to bother with those. Most printers are not going to be able to do that. Unless you have a crazy all metal hot end, you know. Standard nylon, sure. Standard nylon, we're looking at glass fiber, PETG, high temp PETG, PLA, ASA. Should have ASA over there, not looking at that one, looking at this one and that one. Okay, so that is what we're looking at. So first we're going to start off with PLA and compare it down the line. Again, you guys should be familiar with this other one. Again, disclaimer at the beginning of this video. If you do not know, we're going to be looking at mechanical properties of materials. If you do not know how to read mechanical properties of materials, go ahead and check out the video in the description. That is an intro video to understand what all these mechanical properties of materials do, and also so that way you can understand everything I'm talking about in this video. After you watch that video, you'll be able to go on your own, online, to any sort of place that has these technical documents, like 3DXTech, and being able to compare them apples to apples to figure out which material is best for your application. Also, another point, I did pick up some 3DXTech PLA, PLA Carbon Fiber X, the Carbon X line. So I'm going to check that out and see how it is in bending, how much differ it is. Alright, so make sure you check out that video, and then make your way back. If you've already seen that video, or you just came back, welcome back, and let's go ahead and get started. Alright, so PLA, again, if you remember, tensile strength 56 megapascals, modulus, which is the stiffness, 2865, percentage 8%, elongation of break, flex, a little bit higher than tensile modulus, and then flexural strength twice as high, ultimate pressure. Here we see that the polycarbonate ABS mix, 59, a little bit stronger. That's interesting. Tensile modulus 2200. Whoa. Tensile elongation at break 75% at that much stiffness. Wow. That's amazing. That might be something to think about. This might be one to look at. The polycarbonate ABS mix, the 3X Max from 3DTech. Wow. Same, even stronger material, almost as stiff, but what is that? 9 9 times longer stretch before breaking. Flexural modulus quite a bit lower, flexural strength quite a bit lower. So that's interesting. Definitely keep that in mind. Now we have polycarbonate ASA. So again, if you're not familiar with ASA like I wasn't, I guess it's called acrylic styrene. So it's a mix between acrylic, styrene, and acrylite. So acrylic, I think, is just acrylic and then acrylite. So I think this is basically acrylic mixed with styrene, I believe. So that's what that is. Interesting, I haven't really seen this too much. I might need to get my hands on that to try that. So here it doesn't, oh, here you go, polycarbonate, acrylic, styrene, acrylate, there you go. So here, that may be exposed to UV environments, so it does not degrade under UV. Very interesting. Okay, still the same standard, so we can compare them apples to apples. A little bit less strong, definitely not as stiff, yet 35%. So the polycarbonate increases this by a lot. So even polycarbonate is higher than ABS, which I believe that one's polycarbonate. So 35%, that is a little bit over 4 times the stretch. Definitely not as stiff. Pretty close to as much flex. So between these two, not a lot, right? So actually what I think I'm going to do is I'm going to compare these two here, this one and then the ABS, and then I'll move this over here and compare them to the rest. Okay, so ABS 41, lower stiffness. Wow. So no even higher glass temperature, so a little bit more stability, but also kind of harder to print, I guess you could say. So right here, polycarbonate ABS beats out ABS. We don't have any issues with it lowering its stiffness or lowering its strength. It increases strength, increases stiffness, and does not add brittleness to it. So polycarbonate absolutely reinforces ABS. Makes it a very good printer material. However, here we have bed temp 110, so basically the same printing practices, and it's just a little bit more dense. So definitely a good substitute for ABS. Polycarbonate ABS, definitely a good substitute. Alright, let's go again here. PLA to the next one, polycarbonate ASA. A little bit less strong, a little bit less stiff, 4 times more, a little bit less stiff and flex, and definitely not as strong. And it's almost the same density, and you need a heated bed. So this one, I would say just for the UV resistance, let's compare it to standard ABS, 41 to 55, 195 to 2100, and obviously it's quite a bit more stable under temperature. 55, 2100, quite a bit stiffer, stronger, more flex, better in flexing. Stronger here, higher. So still better than ABS. However, here against the ABS polycarbonate mix, 55 to 95, 2200 to 2100. So more stiff, twice the flex, obviously a little bit over twice, a little bit like 2.5 times. Ooh, not as stiff and bending. Interesting. Well, not as stiff and bending here, almost 86, 85. Quite a bit better stability under temperature, quite a bit higher heat distortion. So polycarbonate ABS beats the polycarbonate ASA as far as the mechanical properties, but what ASA has is the printability and UV resistance. So if you have a printed part, for example, like if I were going to use it, it would be like a solar panel tracker or something like that outside, or like maybe like a water meter hub thing for Wi-Fi. That's what I would print it out of to get the UV protection of the ASA, so it doesn't degrade so fast in that. But another thing is that if this gets inside of the ocean system, also it will. If this gets in the ocean, it will hold up its shape before getting broken down too much. So it'll float up on the surface, so somebody can pick it up. So that's also pretty interesting. All right, next one. Standard ESD, the electrostatic dissipation, whatever. It's basically for electrostatic discharge. It's to prevent that from happening. So this is very good with electronics, right? PLA, so yeah, this is very good with electronics to house so it doesn't conduct any and short out your boards or whatever. 1.24, 56, 68, 2865, and we're again PLA to the polycarbonate ESD, 2300, 8, 6. 3100, 3185, 2410, 95, 115. Okay, so very interesting. It lost, so I guess the polycarbonate is not what adds the flex, it's when you mix it between the two, not less something in here, the conductive additives are bringing this guy down. But with the mix, it seems to add quite a bit of extra strength, quite a bit of strength and also flex, which we'll compare those mixes here in a second. So obviously twice as much stability, twice as much stability on, 3 times as much stability under pressure almost. The same density, exact same density. Okay, ABS, a little bit more dense, a little bit so stronger, more stiff, almost as much flex. 2410, definitely more stiff, just as strong. So this one, if you're looking for stability under temperature, then I would go with this over ABS here still, because it's only slightly under. Oops, not done with that one yet. Okay, polycarbonate ABS mix versus the ESD polycarbonate. 59. Ooh, not as. This is definitely stronger. That's actually, I don't think I noticed that. This is definitely stronger here. So ultimate before failure. It's pretty good. So that's why they pick polycarbonate and make it out of bulletproof glass, because it has that high value there, and also it flexes a little bit. 68. Oh, more stiff. Okay, so standard's more stiff. Okay, so we have a little bit loss in stiffness, but drastic gains in flex, and just slight, like 40 megapascal drop in the flex stiffness, and then like 9 here, and then we lose a little bit of temperature stability. So again, polycarbonate ABS, way better mechanical material properties than this guy, than the standard polycarbonate. Again, I don't know if that's because of the ESD additives. Here, tensile strength 55 for the polycarbonate ASA mix, 55, 68, 2100, 2300, 6, 35. So this one is comparable. So yeah, with the UV resistance of the ASA, it's pretty good there. But so yeah, it's pretty comparable here, but quite a bit more flex, and still just as good, and quite a bit less dense, and still just as good thermal properties. All right, we have quite a bit more left. So again, back to Ecomax PLA, stiffer, and this is the hips, high impact polystyrene. So also you can see that here so basically with this acid, orange peel solvent, it will basically dissolve the support. So this is what you have in like the U-print and stuff. This is the dissolvable supports. So there you go. Especially suitable for dissolvable support filaments for many resins, including those that contain ABS and ASA resins. So it's also an excellent standalone print, offering a smooth, low gloss surface and ABS-like properties. So, yeah. So this is the dissolvable support material with a green solvent. So let's go ahead and take a look. So HIPS, high impact polystyrene versus PLA, less strong, half as stiff, a little bit over double the stretch, half as stiff, half as strong. So that's interesting. So polycarbonate ABS is extremely more impact resistant than HIPS. But another thing, also a disclaimer about polycarbonate ABS, I heard the smell is atrocious, by the way, just to put that out there. When I talk to some of the manufacturers that manufacture these, they say that like you cannot be in the assembly room with the machines running when it's putting that stuff out, because it's just the smell is atrocious. So also be very careful. A lot of fumes with that polycarbonate ABS mix. Both are not very green materials, so both of them are petroleum based, so you get double whammy on that. And also they're different, so one's going to secrete different chemicals when heated compared to the other one. So you're going to have two different gases secreted when you print both of them, so be very careful. But I'm liking that combination there. 2865. We already went over this. A little bit more stability here as far as temperature. This is the ABS versus the HIPS. 4143. Quite a bit more stiff. This one's more strong. This one's less stiff. This one's almost twice as much flex. This one's more stiff. This one's less stiff. This one's less strong in flex and less stiff in flex. And a little bit lower, a little bit lower. So maybe ABS might actually beat out this one, unless you want just a little bit more impact resistance as far as the material elongating when you hit it. Polycarbonate ABS mix. We are going to compare those polycarbonate ABS versus the HIPS. Tensile strength 43 to 59, so definitely not as strong. Tensile modulus 2200, 1100, definitely not as stiff. 75 to 20, 3.5 times stronger. Almost 4 times stronger actually. Almost double as stiff, obviously not quite there. This is double as stiff. Flexural strength 86. Wow, just absolutely incredible. This polycarbonate ABS mix is incredibly tough. Look at how tough that material is. 110, this is 100, ABS is 110. So if you could print ABS, you're way better off with the polycarbonate ABS mix if you could get away with the smell. So if you get away with the smell, then you go with the polycarbonate ABS mix. You will not go wrong there as far as that flex goes. It might even be up there with alloy 910 from Tallman 3D. As you remember, we went over that. I believe that was like 35%, and it wasn't as close as that to the PLA. So this is probably up there with a nylon, which is crazy. It's 43. Yeah, we already went over this. Yeah, less temperature stability. This one has better temperature stability, so it's just all around beating it up pretty good. Polycarbonate ASA 55, stronger, more stiff, more flex, stiffer in flex, stronger in flex, higher temperature stability, a little bit hot. This one's a little bit higher density, the polycarbonate ASA. So ASA beats out HIPS as well. Similar bed temperatures. I noticed that the ASA has that high 270. So I think if you go anywhere past 250, you're gonna need a all metal hot end. You might melt. Oh yeah, the ESD polycarbonate, that's way too high. Alright, so I just noticed that. So you might not be able to print these with that high temperature. Alright, with the hips, versus the ESD polycarbonate, 68, so stronger, higher tensile, three times more flex, quite a bit stiffer, flexural strength, quite a bit stronger in flex. Definitely higher glass transition, definitely higher heat distortion. Yeah. Yes, 270, printed at 290. So what's this low range? Yeah, 270 minimum. Okay. Yeah, so let's see if there's any other ones. We didn't even get a chance to look at the PETs, because I want to push that to so we have 1, 2, 3, 4, 5, 6 other ones to test. We're already at 22 minutes, and here we've done 1, 2, 3, 4, 5, 6. We've done 6 here. So 6 here, 1, 2, 3, 4, 5. 5 there. Alright. So what I'm going to do is I'm just going to do final remarks on these, and then I'll have to do another video on the rest of these here. Alright. To compare the rest of these here to these. Because I would like to get in my final remarks on here, and those are going to take a while. So let's go ahead and close this down. And then in the second part of this video, so this will be part 1. Part 2, I'll be talking about the combined between all of them to get some to get final remarks. So definitely check out part 2 before you decide between all these, because I'm going to compare all these rest of these, and I'll give you a definitive answer on which one of these I think is best when you compare them all apples to apples. So let's go ahead and talk about this. PLA, ABS, polycarbonate ABS, polycarbonate ASA, ESD, polycarbonate, and HIPS. So, yeah. So if I need to, I'll bring some of this over here. So. Let's do it all in one piece. Alright. PLA, of course, as we know, very brittle, but very high tensile strength. Well, this particular, the EcoMax PLA, quite a bit more flexible than most PLAs that we've looked at as far as the technical data sheet. But very low glass transition temperature, and very low distortions under pressure, so very low temperature required to distort it. And also very high density. So let's go ahead and take a look. Obviously, PLA beats out ABS as far as 3DX, the 3DX ABS versus the EcoMax PLA. The EcoMax beats out the ABS hands down. The only thing you get extra with this is the higher glass transition temperature, so more temperature stability and slightly better flex. So if you want temperature stability, and generally, like I said, on most, which I'll give to all of these here that are higher and higher melting temperatures, which the rest are, that it makes printing harder and harder to do when they have higher and higher glass transition temperatures. Alright, so ABS only if you want more temperature stability and a little bit more flex. Polycarbonate ABS, wow, the hidden gem so far in this part 1 of the 2-part series of the rest of the 3DXTech filaments. 75% elongation at break, and a little bit, I believe it was even a little bit stiffer than PLA. Yeah, a little bit stronger than PLA, and not as stiff as PLA. 75%. In flex, it was quite a bit lower, but the strength was also quite a bit lower. But the even the glass transition temperature quite a bit higher for the polycarbonate, and distortion temperature also quite a bit higher. So hands down, if you can print this, and you do have a nice open ventilation room that you're not worried about this, this smell. I haven't printed it yet, but I've heard that the smell is very bad. So be aware of that. So watch out for the smell of this guy. Also with the bed prep there, you see that it wants a special bread prep with a ABS slash acetone gel, something like that. So if you can print this and you could deal with the smell, this is one of the this is the only ABS I would probably do. Also, of course, as you know, with the glass transition temperature, and luckily for us, the heated bed is similar. So if you could print ABS, you'll be able to print this. And also with the extruder temp. So like I said, if you could print it with your all-metal hot end, because read up on the Teflon, the melting temperature of Teflon, because if you put that guy in there and heat it up, it might you might melt your liner inside. So check that max temperature. You'll probably want to print at the 270. That is the minimum extrusion temp here. But quite a bit, definitely a lot stronger than ABS, a lot stiffer than ABS, and 7.5 times the flex of ABS, 7.5 times the toughness of ABS. Again, if you remember, toughness is the area below, under the stress strain curve. So 7.5 times the 7.5 times 2, so you're like 15 times tougher than ABS, and also another 37 degrees C more stable under heat. So one of those ones to look at and try out if your printer can handle that. Make sure you check on your hot end before you mess with that. ASA, which is the UV resistant 3D printer material, it's got good flex, but kind of low on the actually. So here, the only thing that's different between here and the polycarbonate, oh, this is the polycarbonate ASA mix. Okay, sorry, I thought this was just standard ASA. That's why it's still pretty good. So the polycarbonate ASA mix, is a good alternative if you want polycarbonate. If you want to use polycarbonate ABS for a machine, but you want it to be outside. So if you're trying to do like a mechanism, for example, like I said, some sort of solar panel, sun follower or something like that. It's got gears and stuff like that, and you want it to be relatively tough because it has to move like a very heavy solar panel or something. Then this is definitely one to go with because it has the UV resistance. Now, I don't know if I quite agree with that because you still have polycarbonate in it. So I think you're limited by the half polycarbonate and the half ASA. So I think that you just get a slight increase in UV resistance. It's not nearly as good as our full ASA, which it doesn't seem like I have that on here creating to go between those two. So again, if you have outside machine, go with the ASA. If you have an inside machine, go with the polycarbonate ABS. ESD polycarbonate by itself, polycarbonate extrusion temp 270, that's pretty high. Tensile strength 68, it's slightly higher than the tensile modulus. The flex is slight. Under tension, it's slightly stiffer than the polycarbonate ABS mix and the polycarbonate ASA mix. The tensile elongation is very low. The flexural modulus is pretty close to PLA. Actually, PLA is 115, and then this is 86. So it's a little bit better. And then quite a bit better glass transition temperature and heat distortion temperature. But you have to have 120 bed, and again 290 C print temperature or 270 C minimum. So I think that the ABS, if you go with the polycarbonate ABS or the polycarbonate ASA, way better to pick that over the ESD polycarbonate. Again, one of the main reasons to get the ESD safe polycarbonate is if you're doing electronics housings and you don't want to have any sort of conduction through your filament to basically ground or to short out your electronics. So this main use is going to be for printing electronics housings. And also keeping those safe, very impact resistant, but it's very brittle with 6% elongation at break, very high print temperature, etc. There's probably the 3DXTech also has a lot of other ESD safe filaments that we might need to check out later, like PETG and ABS. Probably the PETG would probably be a better option. I have not yet checked into these, so we'll have to look at that. But something with a lower print temperature would definitely be a better option, and maybe something a little bit flexible, like what I think the PETG is going to be, which I have not checked yet. Which I could take a little peek. Yeah, so go with probably the PETG. Probably the PETG is going to be a better bet than your polycarbonate, because PETG prints similarly to the polycarbonate, similarly to PLA. As you see here, it's 60 to 70, and fusion temp somewhere around ABS, but yet still low. So this is probably way easier to print. So I'd probably go with the PETG ESD rather than the polycarbonate. But we'll compare those again in the other video. Sorry, here's the polycarbonate. All right, finally the hips. Hips, it's one of those that's kind of in the middle. It kind of doesn't really have like a place, besides of course that it's a great dissolvable support. So it beats all these other ones hands down as far as if you have a dual nozzle printer and you want to do dissolvable supports, this is your guy. But if you're not doing that, this guy is just less dense, not as strong, not as stiff, definitely not as flexible as ABS, polycarbonate ABS or polycarbonate ASA. The only thing I would compare this to is what it's close to is the ABS, which this is definitely not as. So if you want like a flexible ABS, and then if you could print ABS, you could print hips. That's probably the only thing that I would use it for, is if you wanted, as far as the mechanical property material, is if you want something slightly, almost twice as flexible as ABS, then I would go with this. But other than that, it's a great dissolvable support. Again, so let's go ahead and summarize. PLA ABS, we're familiar with that. PLA obviously extremely stiff, the stiffest out of all of these. So if you want something stiff and strongest, that's it. Some of these are stronger by a little bit, but it's the strongest under tensile and under flex out of all of these. The strongest and the stiffest. But it has the lowest TG, the glass transition temperature. So it will basically lose its dimensional stability under temperature at the lowest temperature. ABS, kind of that weird, semi-tough, very difficult to print kind of thing. Polycarbonate ABS beats out ABS hands down. So if you can print that higher temperature and that high bed temperature, and you could handle the smell, you have a nice open room, I would go polycarbonate ABS. Polycarbonate ASA, very similar, not nearly as good as quality as ABS. I would go with the polycarbonate ABS for a machine that's inside, not exposed to sunlight, and polycarbonate ASA if it's outside. If it's designed to be outside for most of its lifetime, use that. Or use the standard ASA. ASA is probably, or ASA is by itself is probably going to give you the best exposure. But similar print, so yeah, that's similar print settings. So that's basically it. If you're going to use it outside, use the ASA. If you have a machine that's outside, if it's not a machine, if it's just sitting there, use standard ASA. If you're using a machine that's inside, use the polycarbonate ABS. Electrostatic polycarbonate, very difficult to print, not nearly as flexible, pretty stiff. So I guess if you want a stiff, very stiff, if you want a very stiff 3D part enclosure, I would go with this guy, but it has a 270 degrees C print temperature, 120 degrees C. So again, if you could print that and you want a very stiff electronics enclosure, then I would go with this guy. But if you want a flexible material, if you want a flexible, tougher electronics enclosure that's maybe like almost like a phone, something that was carried around and is designed to be dropped, or even possibly like stepped on or something like that, then go with the PETG, which we'll compare in the next video. Hips, the second part of this video. Hips, use it for dissolvable sports, pretty much. Otherwise, use Otherwise, use ABS. It's only going to be used if you want something slightly more flexible than ABS. And that is basically it for this video. Our hero of this video seems to be the polycarbonate ABS mix. Crazy stats. Very interested in using some of that. Obviously, check your printer before you try printing it. Do not melt any of your liners inside, your PTFE liner inside, because you'll have a bad day. And you basically ruin your printer, and now you need a new hot end. Alright, this is part 1 of this video. On the second part of this video, we will be checking out the other 5 materials, and then maybe some more of those, the ESD materials. So, that is it for this video. Guys, please check out the second video, part 2, coming soon. This has been Steven from the Green Engineers. If you guys like this video, please subscribe for more videos like it in this series and other series as well. I'll see you guys in my next video, my research video series. I'll see you guys in the next video. Thanks for watching. Take it easy.